All right, welcome back to Mr. Pianos with Geometry. This is Unit 1, Topic 1, Day number 2. So we're going to start off with a, once again, we're learning about vocabulary terms and learning how to write using correct notation. It says match the definition symbol and the drawing. So very similar to what we're going to be learning about. So we learned some of these terms already. A plane, okay, we didn't talk about plane in the last one. So a plane happens to be like a flat surface that extends in all directions. And that would be choice B right here. We have plane, obviously plane can be written plane ABC, so that would be choice I. And this is what a plane looks like. So we use what looks like to be a parallelogram diagram, but technically planes go in all directions infinitely on a two-dimensional surface, not three-dimensional. So like a piece of paper only extends in all directions everywhere. So that would be choice M. A segment has two endpoints, so it's kind of like a line, but it has two endpoints. So that would say n endpoint at location. So part of a line also shortest path between 2 points. Okay, so that's this one. So it has two endpoints. That would be choice F because it has no arrows on top for the notation. And that would be K because it, once again, it has two endpoints. Rays extends forever in along a given direction. Okay, so that's A. And then we have J. And that would be ray, which is O. A point. A point is a specific location. It has no shape, no size. That would be point D. That would be, the answer would be D, actually. So point A would be capital letter, so that would be H. A point would be N. And then the last one we have is a line. So a line says part of a line to one side of an endpoint. Oh, that's a right. Which one did I just choose? I chose A. Extends forever along a given direction but has no thickness. Okay, so let's switch that up. So A is our line. C, so I'm thinking of lines, extends in both directions. Did not specify that. That's what threw me off. And goes to one side with an endpoint. That would be C. So a line would be G, and a line would be like L. Then obviously K was a segment. Forgot to cross that one off. Okay, and there we go. All right, so skipping through the homework. So let's get to that vocabulary. So we left off with vocabulary that can be mentioned with 3 capital letters. So angles, as I know we mentioned in the last video, we have like angle ABC, which would be this angle right here because you're connecting A to B to C. Something that's very important is that the middle point should always be the vertex. So you can go CBA or ABC, either direction, as long as you can draw the diagram without picking up your pencil. So like this, or backwards. But if you say like BCA, BCA would be a completely different angle. BCA would be this angle over here because you're connecting B to C to A. So you can never start with the vertex because otherwise it's going to be a completely different angle. Triangles. Triangles also need to have 3 letters, obviously. Now, the symbol for triangle is just what looks like a triangle. So if I say triangle ABC, then clearly I am talking about this triangle here, connecting all 3 of those points since it's a triangle, not an angle. So the symbol does matter quite a bit. A plane, I know I talked about this in the warm-up. So a plane, we draw looks like a parallelogram. It's a flat surface. It extends in all directions. So it's like a piece of paper that you're writing on, but it goes, I know technically paper does have thickness to it, like a 1/10 of a millimeter or something very, very small. So ignore that. So planes don't have any thickness, even though a piece of paper technically does have thickness to it. Like if you have 100 sheets of paper, you can clearly see its thickness. But planes don't have thickness, but they do extend in all directions. So if you look at this cube here, there's a front, a back, a top, a bottom, a left, and a right. So there's all sorts of sides that you could use as planes. Now, planes don't have any ends, so technically those sides aren't planes unless they extend in all directions. What you see here cutting through the center of this cube is this blue, what looks to be, that is the plane that we're talking about. So we have 3 points on that plane, P, Q, and R, that are slicing through that cube. Now, you might have also shapes that have 4 or more capital letters. So like quadrilaterals clearly need 4 points because they have 4 vertices or 4 sides. Pentagons would need 5, hexagons would need 6, and etc. Obviously, the more sides that a shape has, the more vertices it's going to have, and therefore you need to use all of the points that are on that shape. All right, shapes named by a number. So sometimes we do name angles by numbers, like this would be angle 1, and this could be angle 2. Angle 1 would be angle JKL, for instance, and angle 2 would be LKM. A number must be in the interior angle. So notice where 1 is. It's this angle right here. It's in between this and this ray with K as its vertex. You may also write it in your number into the picture. It isn't already there. Okay, so like, yeah, if I put 3 here, then obviously that's going to be angle 3 now. There cannot be a ray dividing an angle. Okay, so what I'm saying is you can't have a ray like this and call this whole thing angle 3. So the numbers need to be between the 2 rays, not on the ray. All right, what do you think they would look like? All right, so in this last part of the video, we are going to be drawing based upon what we see in the directions. Line J and line K are intersecting. Remember, they're lowercase, so those are not the names of points. So let's say this is line J, so I don't put that at a point. That is the name of the line. And it also says that line K intersects it. You can put the letter of or the name of the line. That did not mean to be a capital K. Sorry, I can't really write lowercase k's very well. I guess it's supposed to be something like that. And they intersect at point Q. Now that's going to be capital Q. And I guess I kind of messed up over here, didn't I? So I need to be careful with that. It needs to be a lowercase j, not an uppercase j. All right, angle FGH. Now, we don't know the size of the angle, but to be completely honest, it really doesn't matter. I'm going to make it an acute angle. We know that this has to be G because it's the vertex. It has to be the letter in the middle. And then I'm going to put 2 points, 1 on each side on each of the rays, and it really doesn't matter which one I call which. This is F, this is H. Then we have angle FGH. Once again, it could have been a right angle, could have been an obtuse angle, could have been any kind of angle. I just decided to go with an acute triangle. Acute angle. We have line segment JK and line segment AB intersect at point W. Okay, so we have endpoints for segments. Capital J, capital K. And then we have intersects. It doesn't say how, so we have another. Oh, no, I'm sorry. It's kind of hard for me to see. That looks like that says a line. All right, so it's line AB, so I need to put points here. Here's A. Here I'm going to put B. And that they intersect at point W. So intersect means to cross. So that intersected point is W. That's where the line and the segment cross each other. That would be the word intersect. Triangle RSD, a triangle with corners RS and T. Okay, it can be any kind of triangle we want, so that's easy enough. So I'm going to put R here, S here, and T here. And once again, the order does not really matter. And then last but not least, we have a circle with center C. Now it did say don't worry about if it's perfect or not. I'm going to draw to the best of my ability what looks to be a circle, and then I'm going to put a center C right there. And then these are all the points that are equal distance. And you can make the circle obviously as big as you want, as long as the entire part of the circle is the same distance away from the center. All right, list as many things as you can see. All right, so this is the last thing that we're going to be doing here in this video. It says share what you wrote with somebody. So I'm just going to talk about what I see. First of all, I see 2 planes. I see a plane S. Now, something I have not talked about in my last video is that the name of a plane, and I don't think this is the best example here, should be italicized. Now, I really can't do that very well. So something like that for plane R. So this is really just a capital letter. That's kind of a mistake. It should be an italic. If you use like Microsoft Word, you probably know what I'm talking about. There's a capital I on Microsoft Word that makes the word italic. It makes it kind of look cursive. So names of planes are always supposed to be in italics. Same with this S. That really just kind of looks like a capital S. So that's kind of a mistake. So we have plane S and plane R. And we'll get more into talk about planes later on. You can also name planes by 3 non-collinear points. So you can't say like plane HJK. You can't say that. But you could say plane FJK because those are not in a straight line. So as long as they're not in a straight line, you can pick any 3 points on a plane and call the plane that. So once again, starting from the beginning, we have two planes, plane S and plane R. On plane S, I would say we have 2 lines that look parallel, but we don't have any proof. We have line L and M that kind of look parallel. On line L, I would say there are 2 points, F and G. And on line M, there are 3 points, H, J, and K. And then on plane R are 3 points that look like they make an isosceles triangle. Once again, and we'll talk about this all year long, looks don't prove anything. I'm just trying to describe what I think it looks like. So it kind of looks like an isosceles triangle. It kind of looks like this, but without the markings, so I can't prove it. And those 3 points happen to be X, Y, and Z. So we have triangle X, Y, Z on plane R. And I think that's pretty much everything that we see here. We could also say maybe a plane S is above plane R. Keep in mind that this picture is made to look 3-dimensional. So we have like plane R here and plane S above. All right, I think that's about it. That wraps it up. So let me know if you have any questions or concerns about this video, and I'd be more than happy to help you. Have a wonderful day, and I will see you again on the next video.